Alright, we're going to do Chapter 8 in a nutshell, just so you have a little bit of prep before M-Step. I'm just going to give you the very basics of the chapter. So the chapter is on surface area and volume, and there's 4 sections to this chapter. We're talking about three-dimensional figures, surface area of prisms, surface area of pyramids, and volume of rectangular prisms. So we're just going to very quickly put it all together and make a little bit of sense of it, and then we'll go over it in class at a later time. Now, to start with this, we're going to start with drawing solids, and there's steps to doing so. Obviously, you would use a straight edge when you were doing something like this, but because we're going so quickly, I'm just going to kind of show you here. So, drawing solids of a rectangular prism, so this is rectangle, to make it look three-dimensional. So, you would draw 2 identical bases, kind of like this, and then you would do you connect the corresponding vertices, and vertices are these points, like from here to here is a vertice. These are what you're going to actually do, are connecting, making sure that they go to the same vertice that they would match. And then you would change any hidden lines to dashed lines. So because I can't erase on here, I'm just going to draw the lines that would actually be hidden. So this line in the back would be a hidden line. This would also be a hidden line, and this one would also be hidden. So basically, if you can envision yourself looking at this, you wouldn't be able to see those lines if this was a real box. I'm just going to kind of put those back over. You wouldn't be able to see those lines if it was a real box because they would be obviously colored because it wouldn't be see-through. And to draw a triangular pyramid, you would start with a base and a point. So our base would look like this, and a point would be right above our base like that, and then you would connect the vertices of the point, or from the triangle to the point. So all vertices, which would be pretty much your corners, would be connected, and then you would change any hidden lines to dashed lines, and I think I can do it because I haven't stopped recording here. So these would become like dashed lines back there, and then you would just kind of fix it up. This again is if you were sketching it, so we wouldn't be able to see those lines in the back. So the first thing that we're going to do for 8.1, or I'm sorry, 8.2 would be surface areas of prisms. Don't worry about the sections, we're just kind of going to go over this. So basically, you got to really know what a prism is. This is the best way I could kind of show you the difference between a prism, pyramid, and before we kind of get started. So a prism is a polyhedron, which is basically just a shape that has 2 parallel identical bases, and then it shows you what are the bases here, and then it shows you the internal faces or parallelograms the lateral. So you're looking at some key terms that we're not going to go over right now, but just kind of give you an idea of what does a prism look like. This is it. What does a pyramid look like? It's got a base that's actually a square. And this one has a base that's a rectangle. But if you look at the difference, you'll see that the base tells what kind of prism or if it's a pyramid. If I had a rectangular prism that looked like this, and it gave me measurements, and it said find the surface area of the rectangular prism, you would have to kind of unfold it and look at something that represents the solid, but it's called a net. Okay, so you'd unfold it and it would look like this. So my net would look like this, but now I have to figure out where do my measurements go. So my top, we were saying if it was this line here, oops, I should get a different color. If it was this line here, and my top would be the same measurement, so this would be 7 inches. And then I have a side that is 4 inches because my side over here is 4 inches. And then I had my height, which was 3 inches, so that would be the front of my shape. So right here. And then you can kind of take some guesses at what things could be. So if this length from here to here is 7 inches, that means obviously this one is 7 inches, that's 7 inches, this is 7 inches, this is 7 inches. I mean, so you can kind of see where some things are happening. This is 3 inches. If this one is 4 inches, so is that one. That means this is also 4 inches. So you kind of get what I'm saying here. The point is now I need to find the surface area of a shape like this. So I have to really think to myself, all right, what all do I have to do? I'm going to start with this. This is my top, we call it. So I have, my top is a 7 by 4. So what you're going to do is you're going to write down all that information. 7 times 4 will tell me the area of that actual rectangle. And I'm going to do all of them, and it will look like this. So these are all the dimensions of what I'm dealing with, and you know, it's length times width. That's how we find the area of this, and you should probably know that each of them is length times width. So all of them would equal this. And now all we do is we find the sum, or we add them all together, and we end up with 122. And you have to put a label on it. It would be inches, and it would be squared, because we're talking about surface area, or area, and we know the area is squared. So just remember, if you see any problems that we're talking about surface area, you're not finding all that area inside of this rectangular prism. You're finding what is each side, what is it equal. So you could even just look at something like this and say, all right, from here to here is, oh yeah, it's 3 inches. Well, 3 times 7, but just make sure you get all sides. And there would be a total of 1, 2, 3, 4, 5, 6. So you have 6 different measurements that you're taking, and add them all together, you get the surface area. Now we have the surface area of a pyramid, and you're going to have to learn how to do a net of one of these. But what we would see is we would have a square pyramid. So on a square pyramid like this, we have to notice that our base is a square, and then we also will have a height in here, which is this pink line. I know it's kind of hard to see, but anyway, that pink line would measure 10 inches, and then my base would be 7 inches. So if I had something like this, I want to know what is my net, and how do I figure out what my surface area is of something like this. So what you would do is you would draw out your square for the actual pyramid. I'm going to redo that one. Okay, so you're going to draw out your square. Okay, and then with that, if you got to pretend or kind of envision it just kind of falling. So if you had this actual figure over here, what would it look like if it just collapsed? All the edges just kind of fell out. And that's how you kind of have to picture it. So now that I have this, this is my bottom, and the rest of them are just my sides. And so my sides, I know that I have a measurement of here. That's my height. So all of those heights will be 10 inches. Okay? And then this area, or this measurement here, would be 7 inches. And so the same for each of the sides. So now we have to find the measurements of all of these. If we have area equals length times width for a square, so our bottom is a square, rectangle, I know it would be 7, but this happens to be a square, so it's 7 times 7, right? Because all of these sides are the same. But my side is a triangle. We have to remember the area of a triangle is not just length times width. The area of a triangle is 1/2, okay? Times your base times your height. So that just means we have to use that area to fill in over here. My base of my bottom was was 7, so I would do 7 times, what, I actually don't need that in there, do I? 7 times my height, which is 10. So I would have, order of operations tells me to do multiplication first. Well, it's all I got is 1/2 times 7 times 10, so I could do 7 times 10, which is 70, times my half, and I'm going to end up with 35. So each of these sides is 35 because they're all the same. So now I have, oh, I didn't do my 7 times 7 is 49. So now I have to add all these up. And I get a total of 189, and it would be 189 inches squared because it's a total surface area. So this time we're going to work with the volume. So they use rectangular prisms, but this could be any shape. So you would kind of start off with a rectangular prism like this, and then the measurements would look like this. Okay, so this part right here, my front, would be 23 meters. This side number would be 4 meters, and this one up here would be 17 meters. So the formula for volume looks like this: length times width times height. And this is how you would set it up in class, but just to know how to do it for a test, it would be like this. So V equals length times width times height. And now we start plugging in. Well, my length would be my 23. My width would be my 4. And my height would be 17. So now I can solve. So now I would do, you would figure out 23 times 4 times 17, and you should come up with a total of 1,564 meters. And here's the difference. It's cubed because we're talking about cubing something. It's cubic meters, cubic inches, whatever. So this would have a 3 instead of a 2. Okay. M-step, you got this. This won't be a problem for you. You guys, like I said, review this video, take the notes on it. Do a good job. It's not everything, but this is basically what Chapter 8 is about, and we'll do it more in a class. But I just wanted to give you a little bit of an idea of what you could see, and so you're not completely out in the dark. So, good luck.